Hello, welcome back. I'm Brian Rios from Build Plus, and I'm here today with Evan Burkowski, the co-founder and CEO of Kimaru AI. Evan, thank you so much for being here.
Likewise, thanks, Brian. It's a pleasure to be here. I guess this will be the third interview, so kind of a trilogy that we were doing here.
It feels great to have you back, so I appreciate it. And I wanted to start with what Kimaru AI means and how you kind of came to that idea.
So Kimaru AI, Kimaru in Japanese actually means to decide or to be decided. So we took the verb for deciding, essentially, and use that as the company name. In the same way that people Google stuff, we want them to Kimaru stuff, as in decide stuff. So specifically what we do is we leverage decision intelligence agents. So this is a combination of the decision intelligence methodology and agentic AI to improve decisioning in business processes, specifically in retail, supply chain, and logistics.
Nice. And so how did you kind of land on that being like the area to focus, or like what were the problems that led you to that area?
So it was from myself and my two co-founders' previous consulting work. So previously, we worked at a very large consulting agency that was helping Japan Inc. with digital transformation. And what we found is that although we could help by implementing better like CRM or ERP systems, kind of structuring the data and getting the building blocks of digital transformation in place and have a very large effect, there was still a, let's say, cultural resistance around getting the full impact from those tools in terms of speeding up overall business processes. Anybody who's spent time in Japan knows that decision-making in Japan tends to be kind of the inverse of, let's say, the Western model, where let's use Facebook as an example. Facebook's famous motto was move fast and break things, right? So it was something like 20% planning and then 80% implementation, and we'll work it out as we go. And Japan is the direct inverse of that. It's about 80% planning and then 20% implementation. And we thought, well, to get the best ROI on digital technology, you actually do need to move faster in the decisioning process. So let's take AI, some of the advancements in AI, and apply that to overall business decision making. Now, that relates to the decision intelligence methodology. So one of our advisors, Dr. Lorian Pratt, coined the term decision intelligence, published the first book in 2008, which was adopted at Google. There's now been something like 25,000 Googlers trained on this decision intelligence methodology. But we're combining that with this agentic AI layer that is more practical for actually, let's say, structuring the data required for better, faster decision making.
So in our previous interviews, you've mentioned before that there's kind of this, we're heading for like the digital cliff, and there are productivity bottlenecks that would happen in Japan. Is this kind of what played into this decision to make a decision AI? Or like maybe you can run me through how those are related.
Yeah, exactly. So this is essentially like the third part in a trilogy. So the previous two interviews we did were talking about the upcoming digital cliff, how the Japanese government had put out a report identifying some of the issues around getting the ROI on digital technology and saying that by 2030, there's this potential digital cliff that Japan Inc. as a whole will fall off of. And I think the last interview we did was 4 years ago, right? At that time, I was country manager for Dynamic Yield, which is an Israeli startup that leverages AI, specifically machine learning, for making recommendations around products, matching the correct audience segment with the correct type of products, mostly for retail and e-commerce use cases. Since our last interview, Dynamic Yield was acquired by MasterCard, and so I moved on. And about 4 years ago, around the time of that last interview we did, I was thinking, this technology that we're using for e-commerce use cases is very interesting. It allows us to, let's say, speed up the whole process around more algorithmically making decisions in retail. But Japan is still so focused on monozukuri, manufacturing, tangible items. The whole culture is about building tangible things. how can we take this new emerging technology and apply it to the real world? And how can we speed up those processes and the overall decision making there? So starting about 4 years ago when we were doing that research, I found this methodology that Dr. Lorian Pratt, again, had developed, this decision intelligence methodology. And I thought, okay, this is a piece of the puzzle. And then about 18 months ago, we started this company, Keymatter AI, and together with my two co-founders, they brought other, let's say, missing pieces of that puzzle. So our CTO, Dr. Harish, he worked for 25 years at Panasonic's R&D lab, and he got his PhD in what's called digital humans, essentially creating ergonomic workflows, human modeling environments for manufacturing processes. And that brought an underlying body of research and knowledge that allowed us to model out how humans can better interact with these new agentic workflows. And then our third co-founder, Sinjin, he previously had a consulting company that identified how impactful AI was going to be in overall digital transformation. And he actually headed up a department and hired Harish and myself at the previous company, where we started building the underlying workflows for, well, actually for a use case very similar to what you guys do here. That company was trying to find where their researchers and engineers should upskill so that they can be better deployed for future-proof, let's say, career paths to solve multiple research and engineering problems that were upcoming in Japan. Yes. Right? So it was kind of this perfect bringing together of these, three different career tracks, the identification of a very specific problem that can be solved with AI, and the timing of the technology itself reaching a pivotal, kind of point of critical mass.
Nice. That's amazing. It sounds like there's a lot of layers there. And so one of the things that I want to kind of dive into is like decision intelligence and sort of what that means maybe to someone like me who has like maybe less experience. Like I use ChatGPT, but I'm not necessarily like, I'm not an AI researcher and I'm not building out a product like this. And so I'm curious just maybe to get a little bit more of an in-depth breakdown there. Yeah.
Sure. So the way we usually describe our platform is that it's decision intelligence agents and applied to retail, supply chain, and logistics use cases. So there's actually a lot to unpack there because it's an amalgamation of different technology and different methodologies. Okay. So starting with the first part, decision intelligence. Decision intelligence is a methodology for engaging in machine learning that is more compute efficient. It's the easy way to think of it. So if we look at how machine learning for use cases like predictive analytics and prescriptive analytics, maybe I should define that a little bit. So let's do that quickly.
Okay, yeah.
In the world of AI as applied to decision making, we've gone through basically, let's say, 3 generations. Okay. Descriptive analytics, which is looking at all of your historical data to describe what's going on, find patterns, and draw insights out from that. Okay. Prescriptive analytics, which is saying these are the patterns and this looks like where we're going, so this is our expected future state. And then prescriptive analytics, which says this is what we can do to alter the future state. Here are the actions we can take to affect our desired outcomes, let's say. Okay. And so decision intelligence is a methodology that says, well, these are our desired outcomes. Yeah. These are the levers that we can pull or the actions we can take to affect those outcomes. Now, let's connect the data to model out the effect of those actions just at the relevant points. So it kind of flips the script, because the old way of doing machine learning was based off of analytics. Take all organizational data, everything you can get, all the spreadsheets, all of the sensor data coming off of like the conveyor belts in the warehouse, and everything that you can get, and then pull that all together into business intelligence tools, model it out, look for patterns, and when you find a pattern, use those patterns to train the AI or the machine learning models. And that's a great way of doing it from an let's say, from a, well, McKinsey analyst point of view. But as we get more and more data all the time, it becomes less and less practical and more resource heavy to do all of that. So decision intelligence flips that around and says, we don't need to process all of the data to find out what to do. We need to decide what we want to do. Start with the outcome, then determine which actions are most impactful for that outcome, and then just connect the data to model those actions out there.
Got it. Okay. That's interesting. Yeah. So from my understanding, it's kind of like you said, it's outcomes focused, and it kind of works in reverse, where it's like you're deciding what the prescription would be, then you're looking at what those predictors would be, and then you're looking at the descriptive data that is like that baseline, what you actually need.
Yeah, that's exactly right. And so Dr. Pratt's sort of revolution there was the application of causal decision diagrams or causal decision mapping to any organizational decision. So again, that action outcome connection, and then the data that you can connect to that to make models to predict what would happen and create various scenarios for any impactful business decision or organizational decision. And those CDDs, or causal decision diagrams, are built off of, well, BPMN, for example, business process model and notation, or basically just rules-based business management, which Japan excels at.
Yeah.
So there's a great underlying framework in Japan for modeling most of these processes. We can take existing historical models, and then we find what's most impactful and which data, let's say, is most relevant for the machine learning models to model out that overall CDD process.
Yeah. So your specific focus on like supply chains and retail, something that we've talked about before was kind of this want to help the world almost, like make the world maybe better. And one of the things that can stop the world is these supply chain issues that come up. And so how did that lead to the product or the idea for the product? And was it influenced by the target, or was it more like you had this idea for the product and then you decided the target after?
Well, it started by trying to solve a specific problem that our customers in the consulting business told us they were having, and that we identified that they were having, which was when you try to apply better decision making to business processes, macro business processes, especially in an economy like Japan's, which is arguably the most globalized supply chain on the planet. Japan, imports and exports, imports raw materials, exports more products than almost any other country, and is more integrated into the global supply chain than almost any other country, especially with America starting to turn inward a little bit. That is even more so the case, let's say. And so because so much of the Japanese economy is based off of these manufacturing processes or even services that are essentially exporting their product, financial, insurance services, huge part of Japan's economy, and a lot of these processes are very globalized now. Those processes require very intricate and interconnected supply chains. And so part of this was saying, okay, we've got this decision intelligence methodology. We know that we can improve Japan's overall GDP if we improve the speed of decision making. And that's very basic math, but I'm going to give a quick shout out to Richard Katz, the economist. I'm a huge fan of his. He published a book last year called The Contest for Japan's Economic Future. And it was talking about startups and how they have the potential to, let's say, disrupt and increase the productivity of the incumbent players in Japan's economy, and how that's going to help improve a critical KPI. And this is not in his words, so I'll give you a little bit of creative license here. I'll distill the math down to something very, very basic and say that the critical KPI is per hour productivity. So if you look at Japan's macroeconomic situation, we have a declining workforce and plateaued per hour productivity. And your GDP is basically a calculation of how many people you have working and how much they can produce per hour. Very, very simple math, but let's say that that's the calculation. So when your workforce is declining and your productivity is plateaued, that means the GDP will decline, right? Mathematically, it's a probability. Well, the per hour productivity being plateaued is very strange because over the last 20 years, almost every developed nation has been increasing in per hour productivity. And the increase has come from an ROI on digital technology. So when we dove into those metrics and looked at what was happening in Japan, we saw that plateaued per hour productivity was caused by a lack of ROI on digital technology, and that if we could solve that problem and a lot of the decisioning processes that come from, let's say, somewhat outdated bureaucratic decision-making processes, like the Nemawashi process, which is a stakeholder alignment process, or the Dingi-Sho process, which is a stakeholder sign-off document process. A lot of those processes make sense in an industrial age economy and, let's say, a very paperwork-heavy 90s style economy or rule-based management process. But they don't work in the information age when everything is speeding up and speed becomes the critical factor there, or per hour productivity becomes the critical factor there. So that sort of economic research said, okay, the most impactful thing that we can do with this technology is improve the speed of decision making. The most impactful thing we can do for Japan's overall economy is improve that in manufacturing, supply chain, and logistics. And fortunately, the most structured data sets that can power this decision intelligence-based machine learning come from industries that are in manufacturing, logistics, and supply chain because they have the rule-based business management processes in place already, as well as the structured data sets around like large SKU product files and, essentially the underlying data set that we need to train the machine learning. And I knew this because at Dynamic Yield, we used those same SKU CSV files to train the machine learning for the e-commerce use cases, right? So we could take the same underlying data sets and apply it to this new agentic AI real-world processing for this use case.
That's amazing. I love that. So yeah, I think it's really great. And I think that it's almost like, I mean, this can be applied to any market, but it does feel like, in a way, it's the perfect place to launch something like this. And it's something that you talked about in the other interviews where Japan needs something like this in order to kind of avoid that digital cliff in the future. And so what I want to ask about now is, when you had this idea, you had the concept, you had the research behind it, how did you take that to prototyping? And then how did investment kind of play into that process? Did it play into that process even?
Yeah, exactly. Very much so. So in the past few years since we last talked, there's been a huge boom in the Japanese startup ecosystem. The Japanese government realized that it needed to make some, let's say, structural changes to make it a more startup-friendly nation. I think proving Dr. Katz's research that startups are the key to disrupting some of the incumbents and making them more competitive and improving that per-hour productivity problem. And so Jetro Startups has done a lot of work to bring different accelerator programs to the Japanese market, and we benefited from one of those. So we started the company, again, a year and a half ago, bootstrapped for the first 6 months, and then got accepted into the inaugural Alchemist Japan Accelerator Program. So we were part of Class 1 together with 8 other companies. So that came with both some equity investment. We got enough that we could move from bootstrapping to really get into production of an MVP during the 3 months of that program. And it also came with a lot of coaching, mentorship, and structure. And
sorry for 1 second. MVP, minimum viable product.
Minimum viable product.
I just want to make sure to say that because sometimes, just in case people don't know. Continue.
Right,
okay, sorry.
Yeah. Sorry. If I throw out jargon like that, please help define it.
Yeah, that's fine. So you had the minimum viable product. You're building that out, and then what happened?
Yeah, so we went through the initial 3-month program of the Japan Accelerator, and then it bridges to a 6-month program in the US. During the first 3 months, the coaches really helped us to define the use case. Because we had the high level technological innovation of decision intelligence and the ability to leverage these new emerging AI agents to make it more practical, right? And so we were able to patent a completely new approach to doing this and leverage that to improve business decision-making processes. But then going through the Alchemist Accelerator allowed us to figure out exactly which use case to apply this to. Because our initial thesis was, well, decision-making is so critical for any organization that we should apply this to all decision-making processes. And that is just, it's like trying to boil the ocean. You know, you can't do it for all business processes worldwide all at once. And so the focus that the accelerator gave us was just North America and Japan. So, well, we started in Japan, but expanding to North America, just for retail to start with, and then moving sort of up the supply chain more into the overall logistics, things like demand forecasting, inventory optimization, pricing optimization, but starting with the retail use case. So that focusing lens and coaching around exactly how to do that was the critical, let's say, help that the accelerator gave us.
Nice. And so what are some of the decisions that you feel like this, or not you feel like, what are some of the decisions that this type of technology can be useful for making more efficient, like in retail? Let's start there.
Yeah, so let's think like a day in the life, basically. So most people who work in something like operations or pricing or inventory for something related to a retail function, which has some connection to supply chain, they need to do, let's say, one of 4 major jobs. They need to decide the pricing of items. They need to manage how many of those items get to where at what time. So let's call that inventory optimization. They need to manage how it's going to get there. So route optimization, shipping, trucking, last mile couriers, all of this, even down to position on the shelf. And then connected to all of that is demand forecasting. And those 4 jobs to be done, let's say, are where we've built our platform into 4 unique modules, and then some of our customers are using one or some combination of those. And underneath those sort of products that we sell on the platform are the agents, the AI agents that engage in the tasks that humans used to have to do entirely manually, mostly in spreadsheets, connecting data together, cleaning the data, and then making recommendations. So the typical user used to have to come in the morning, look at multiple different data flows across multiple different software applications, pull that into usually one sort of spreadsheet to rule them all, and then do a lot of work in pivot tables to figure out what are the likely implications of scenario A, B, C, or D. If I make this decision, if I order this many units and I set the price to be this much, how is it going to affect our overall, let's say, sales as well as the demand rolling all the way back up the supply chain. And that's a lot of work. It's a huge amount of work spent in spreadsheets. And so everybody that we talked to said, the number one thing we want is like an AI buddy that will help us to spend less time in pivot tables.
Yeah.
So we built Kimaru for that specific use case. And this is what it looks like now. Say that you're a pricing manager. You would come in the morning, log into your Kimaru dashboard, and you would get a list of recommended actions that you can take right now. You can review those actions and you can accept them and implement them immediately in the action layer, which is usually an ERP system like SAP or Oracle, or warehouse management system or robotic process automation system. That's what the action layer looks like. Or it might be a CSV, because you might just say, okay, I'm going to take this action and we're going to go talk about it with the team. And so you make a report to talk about that with your team, but that's the action that you can take. But so the user logs in and either accepts that recommendation and takes action on it, or pushes it for later, pushes it to a work list where you can go and simulate different decisions and work on that another time, maybe in the afternoon. Or you can reject and override the recommendation. So it's sort of this gladiator style, good or bad. And in the case where you reject and override the recommendation, you can then very easily input your own parameters. So you put in your own metrics, X number of units at Y price, let's say. And that creates a feedback loop where the AI is learning from the human user. So the human user is engaging in their, let's say, critical thinking, thinking from first principles, sometimes creative thinking, creative problem solving, to override some of the recommendations that the AI might be making. And in that process, there's a feedback loop created that makes the AI more accurate over time.
Nice. It's funny because I have this list of questions, and you're kind of covering them just in talking. And so that leads us to the feedback loop. And so how is that important, and how does that optimize the AI over time?
Well, one of the critical things is that what we're talking about here is essentially agentic AI, right? So it's AI agents that have agency, hence the name. They can do things. They have some autonomy. And what you always want when building an agentic AI system is to allow the AI to take some actions, let's say low stakes actions, things like connecting a couple of CSVs together and saying, okay, this date format matches this date format, so we'll connect this together. And then, that type of AI is basically the underlying data cleaning and data connecting AI. And then you have another type of AI, which is more that prescriptive analytics that we talked about earlier, which models out different scenarios and recommends actions that you can take. But in every, let's say, agentic process, you want to have a circuit breaker. You want to have a human in the loop process where the human steps in and says, okay, enough running the autonomous processes, show me your work. How far did you get so far? This is kind of like a, university professor-student relationship where you give the professor gives the student an assignment and the student does it and the professor says, okay, looks good, show me your work. How did you come to this conclusion or that conclusion? So that feedback loop is essentially the AI saying, I recommend this. The human says, okay, looks good, or show me your work. And that allows the human user to check the autonomous processes, create a circuit breaker when there's too much autonomy in the system, and override with their own metrics to create a better reinforcement learning environment. This is generally what we would call reinforcement learning with human feedback, or what is that? RLHF, right? Which is a term that you'll hear a lot in agentic AI processes. And so that process allows real-world AI training. Now, this is important because we're moving from what I would call first-generation agentic AI built off of LLMs, or large language models, which were amazing in how much they could do, but also really, really unreliable and really quite dumb in many cases. And the
imaginative.
Well, imaginative. They required this problem of deterministic processes versus probabilistic processes. Mm-hmm. So most LLMs seem human because of this stochasticism, which is a built-in randomness, right? Which allows you to ask the same question 10 times and get whatever it is, 5 different answers, right? And that makes it seem like you're not talking to a robot. But that's not useful for a work process. Yeah. What you want for a reliable work process is basically an agent that will follow set parameters, basically rule-based, and then come up with a reliable action that you can take each time. And that doesn't work well with LLMs because all of their power comes from the pre-training or the early training data, and then just a little bit of tuning with very short memory windows, right? So this past week, OpenAI, just to sort of, let's say, conceptualize this a little bit more. OpenAI launched extended memory windows. So now you can have conversations that go back across various chats. And it will remember stuff more, and it's considerably more improved, and it should reduce some of the hallucination that comes from that stochasticism. But LLMs are inherently, I would say, the wrong tool. That first generation of agentic AI is kind of the wrong tool for business processes. What you want is LRMs, or large reasoning models, and they rely less on their initial training data set and more on the RLHF, the human in the loop feedback that comes from real world environments. And so we've built our architecture so that we're using more of the LRMs, or the large reasoning models. General good practice is one tool per agent, and then it's a multi-agentic system that rolls up to a central orchestration layer with like a super agent talking with the human. And that's essentially the brain in the overall central nervous system. So we connect all of that supply chain logistics data through this nervous system that's superimposed on the existing systems, not replacing any of the ERP or RPA systems or anything that's already there, but just connecting it all together so that it can now report up to that centralized brain.
Yeah, that's amazing. That's a great analogy. And so would that brain be an LLM then, or is that an LLM then, or is that also an LRM?
It's an LRM. It's a large. The technical term would be more that it's a multi-agent system.
Okay.
Right. So you have multiple agents, and we're using different types of AI. Right. So we've got, essentially this is prescriptive analytics, which is kind of the old workhorse AI that we've been using for 15 years now. The things that will power product recommendations, like we were doing at Dynamic Yield, or personalization scenarios, like just to sort of conceptualize this a little bit more right now, if you and I each logged into Amazon right now, we would see different product recommendations. I would get a lot of book recommendations based on what I'm studying recently, and then I would probably get some product recommendations around my Golden Week holiday plans, because that's what I've been shopping for recently. And you would get different recommendations, right? So that's one type of AI. That's the type of AI that's been powering everything from social media content recommendations to ads through to product recommendations for, again, like 15 years now. Well, that's one type of AI. But then the more recent LLM type of AI is based more on these, general pre-trained transformers that take tokenized conceptualizations of language and predict. They're basically the same type of prediction as when you're typing on your iPhone and it predicts the next word, or you're typing a search in Google and it predicts the next word, just taken out, to be billions of tokenized data points, right? So it's more the next evolution of that, the LRMs, these large reasoning models that, I guess a good way of thinking of it is they are essentially like students who fact check each other's work before presenting it to the professor. So to extend that metaphor a little bit more, it's like the professor says, okay, here's an assignment. And the student says, great, we're going to work on this as a team. So, student A, you do this research, and student B, you do that research, and student C, I'm going to write it all up, and then we'll create the report and present it to the professor. And when you have a multi-agent system that does various tasks like that and then presents to the professor, and in this case, there's a super agent in that process. So it's sort of like the presenting student represents the super agent, the one who compiles it all together and says, here's the assignment. The human then checks. And not every single word, right? But the overall result. So when a professor checks a student's work, they come in at pivotal points. And if everything looks good, they approve it. If something is off, that's essentially the circuit breaker, where you break the autonomous loop and say, okay, human intervention is required here.
Nice. Okay, that's great. And so how has the response been from the customers that you're working with, and maybe the market overall? Like, how would you gauge the interest, the understanding even? What has the experience been like?
So when we started, we knew that we were going to be able to speed up decision making, and that would have a direct correlation to reducing costs for organizations. And one reason, again, why we chose supply chain is because, well, that's a pretty easy sell, right? If we can go and say, well, we'll reduce your time to decision, and that will reduce your overall costs. Having sold B2B SaaS software for going on 20 years now, the easiest sell is always a reduction of costs, right? So we knew that that would be a benefit and that people would probably respond well to that. And our data, as well as the overall industry data, indicates that on average, we can reduce costs 15% for inventory management. What was a little bit surprising is that we also found we could reduce the amount of inventory, period, because we're reducing the amount of inventory that's required to be held in the warehouse, the amount of inventory that is spoiled. And if you've got fresh food products, there's a huge amount of spoilage. There's a huge amount of shrinkage, right? So on average, we've been able to reduce that 35%. But the real surprise was that we could also improve overall customer service, the service of the supply chain itself, by 65%. Wow. So that was a very pleasant and kind of unexpected finding. Yeah. And we didn't look for that at the beginning because we didn't realize, or maybe I suppose it took our customers to tell us that a huge part of what they're trying to do with that supply chain is meet certain customer KPIs. Say you're trying to get enough onigiri to, like rice balls onto the shelf of your local convenience store in time. Well, the ability to actually service that need, if you can do that much better, then you actually meet the needs of your end users, the people eating those rice balls, as well as the convenience store managers as well. So that 65% improvement in the overall customer service sector was a very pleasant find.
Yeah, that's amazing. It's interesting because it's almost like there's like, I get that it wasn't the target essentially, but it is the side effect, right? It is really like, because if you're optimizing everything, then everybody's happier and the costs are going to come down and you don't have as much waste overall, which is where that 35% reduction comes from as well.
Yeah, I think we were a little bit focused on the waste reduction initially because that's also a good story and it's an understandable narrative, right? I mean, if you can reduce the amount of food wastage, that directly connects to SDG and ESG goals, and we have been able to do that. Or for our fashion retailer customers, there are millions of tons of unsold fabrics that go into landfills every year worldwide. And by reducing the amount of unsold inventory, we can reduce the amount of essentially waste from that, as well as all manufacturing processes. Essentially, all supply chain use cases benefit in some way from that.
Exactly. Yeah, it's really amazing, and something that you kind of touched on before, and this is something that I've been maybe grappling with as well, is like how important a human in the loop is.
Yeah.
And then what I want to talk about now, kind of moving into this next section, is like for upskilling, like you mentioned earlier, where should people be focusing in this new era of like using a tool like Kimaru? Like, where do you see the most benefit from learning, studying? Like, what should people be looking at?
Well, I think the human in the loop process is critical. As we look at where AI is going, it's going to be the biggest technological revolution probably of all time, for humans, let's say. It's going to be, hundreds of times more impactful than the internet has been, for example. And we're just in the very, very early stages of it. And so we're still dealing with the hype cycle of having AI that looks like it's going to be practically applicable, right? Every day for the past month, we've heard, or several months now, we've heard of some new agentic AI tool that does something. And now we're starting to hear the backlash of those tools churning because they didn't quite fulfill promises. And so I think the hype is being balanced with a healthy skepticism. So let me try and future-proof this podcast by making some, let's say, recommendations that are more connected to, let's say, career planning, right? We talked a moment ago about the human in the loop and the circuit breaker component. As AI gets more and more powerful, that human in the loop process becomes critical because we need to build in containment into the systems. Science fiction has been telling us for years that we can't have full autonomy in AI systems. This is like the Terminator scenario, right?
Space Odyssey.
And that is legitimately concerning. As we get AI that could take over more and more processes, and we see how unreliable AI can be. It's not sort of the, completely robotic processes that we probably expected. It's very, I like to think of it as George Lucas's vision of what droids would be like in Star Wars, right? Like some of the droids are super helpful. You could probably argue that R2-D2 was the hero of the entire franchise. Like he saved everybody over and over again. But he was a helpful, kind of helper, right? He could fly the X-Wing, but he couldn't do everything that Luke could do, right? I guess, well, he could navigate. Maybe he couldn't even fly the X-Wing. So you can't rely on your AI to do everything. And you have to build in this human in the loop component. And for our specific use case, the supply chain, we actually see a lot of competitors moving towards full autonomy. And that we think is very dangerous because it doesn't solve the underlying problem of being able to make faster decisions. It actually slows them down. So you have to build out your autonomous decision-making process on existing data and conceptualizable use cases. But something very topical that's going on right now is a set of tariffs being implemented worldwide that are not predictable. We don't know what the strategy behind these tariffs is, and it's not something that you can model out using any AI algorithm. In fact, I think the players in the scenario may not even know the end game themselves. I think it's a little bit of, let's say, on-the-fly judgment calls. So there's unpredictability in systems that can only be managed by, let's say, not complete automation, but augmentation, decision augmentation in this case. The AI looking at understandable, predictable parameters, and then the humans applying pretty creative thinking.
So a part of what you're saying, or what I'm hearing is because data is all based on the past, then these fully automated systems can only base their decisions on things that have happened. And when something like the tariffs happen, it can be it can almost crash the entire system, and essentially, especially if it's fully automated, because it's so unpredictable that you can't navigate it in that way. And that's why you need the human to really be able to say, let's stop for a second and reassess what's happening.
Yeah, it's this synergy of human plus machine that is the most adaptable. Now, it's not precise to say that all predictive algorithms are backwards looking.
Okay.
Right. So basically, it's taking existing data and then let's say the methodology of prescriptive analytics is to apply randomization using random forest algorithms and Monte Carlo simulations and all of these different ways to algorithmically predict the likely scenarios. The Monte Carlo simulation, just to sort of put this in context, the Monte Carlo simulation came from the Manhattan Project. It was a way to calculate the statistical probability of the first nuclear reaction igniting the atmosphere and destroying the entire planet. And I forget exactly what it was. I think this was mentioned in the recent Oppenheimer movie. The statistical probability was low enough that they considered it a risk that we could take. But it was not that low. It was actually pretty high. The statistical probability of destroying the entire planet and maybe even the entire universe was there, right? So you want to be able to predict the likelihood of future outcomes based on some ability to model out the likelihood of that scenario, which is somewhat possible within the realm of known physics, but not very possible when you have a completely random actor who is operating under a strategy that only they themselves know. And in this case, I would say that's Trump and the strategy that's known only to him, let's say. So it takes something like, the underlying algorithmic AI and real, human creativity to try to understand what's going on there, and then to make decisions in a more adaptive way. So how does that answer the question about, let's say, how people can future-proof their careers and where people should be focusing on when it comes to using AI in, let's say, work for the next 15 years or so? Well, I think the key thing is understanding that until quite recently, let's say probably until around the 90s or so, you could go to university and train for a career and then go and do that career. And you would have some on-the-job learning and training, but it might not be vastly different, even after 20 years of doing that, than what you were trained for. So if you were trained to be something like an architect, let's say, you would get considerably more experienced and you would get more efficient and a better architect over time, but you would still be an architect, right? Now, let's say, just in my work experience, no job that I've done in the past 15 years existed when I graduated from school. None of it existed. And so it's been a constant process of self-learning and adapting. And I think that's what we both have to get used to in this new world of, let's say, AI-assisted jobs, and also what the AI will enable us to do. And so from now on, all careers will be human plus machine, human and AI working in some way. So if you embrace that and think of it as a process of, not that your job is being taken by AI, but your job is being augmented by AI, and you have now a continual process of upskilling, I think that's the best way to look at it, because AI will affect all work as we know it, all tasks as we know it, for probably the rest of our careers.
So it's keeping up with how things are moving, but then also making sure that you're not resistant to the change also, because I think resistance kind of can slow a person down. That's kind of what I'm hearing.
Yeah, well, I think adaptability is the key.
Okay.
Try to have an adaptive mindset, and that is Homo sapiens' superpower, is using tools and adapting to using those tools. It's what we've always done, and now the pace is accelerating, but we have better tools that allow us to adapt better. So case in point, when we were preparing for this interview, we did our planning, and you prepared some of your questions using AI, right?
It's exactly, yeah.
Right, and because I use OpenAI so much, I could immediately identify which, I even knew which model you used to create those questions, because there are definable grammatical patterns that the AI produces. But it really helps with that sort of a process, as long as you understand that you can't rely on the AI by itself.
Yeah.
You always have to think of the AI as like that little droid buddy. It's helpful and it's well-intentioned, but it's not that intelligent. Like, it doesn't really know what you want. It's just trying to make you happy. So all AI is basically trained by what it thinks will make the human most happy, right? And there's that battle between deterministic and probabilistic models. The probabilistic models have to have some aspect of randomization in order to seem human, but they're not reliable. So you have that trade-off there, right? And all AI that we'll be using probably for the rest of our careers will always need to be checked. It will need at some point in the system, there has to be that circuit breaker, that human in the loop, authentication, course correction, augmentation.
Yeah. Yeah, and it's because the interview example is actually really good too, because just in the course of the conversation, I have to update kind of the questions, or like mold them around what we're actually talking about, because the questions are coming from ChatGPT, and it's kind of guessing what we want to cover. But then when we're actually talking, we have to kind of be aware of, okay, like, we've covered this. This is not something I have to go back to. Like, question 9 happened already. I don't need to ask again, or something like that. And so for someone maybe just starting out, joining the workforce now, maybe a new grad, what advice would you give them to help them better prepare? It's like upskilling, staying kind of on top of things. How do you recommend they do that?
Understand how these systems work. You don't have to be a coder. You don't necessarily need to be able to code something like an LLM, but understand that how the system works, and then understand that this is an alien intelligence. It's not artificial general intelligence, which is, by definition, something that could do all human cognitive processes as well as humans, and then super AGI would be the next step, which is better than humans. It's not that. That's not where we are right now. We have something like ACI, where we have useful buddies that can do some things well, but you always have to treat them like a fresh, first week on the job intern. Eager, very helpful to help with some things, but not able to do everything yet. And so understand that this is an artificial intelligence, an alien intelligence that thinks different than how humans do. I think that's pretty key. And then if you do a little bit of research into how these things are built and how they're likely to evolve over time, you can sort of, let's say, chart a course for where your career will go so that you're able to leverage these tools without, let's say, the danger of becoming redundant over time. There are jobs in terms of tasks that will be completely replaced by AI. But I don't think there are careers that will be completely replaced by AI, because we will upgrade, or we will upskill ourselves to use AI, these new tools, in new ways, which will enhance the jobs. And so those careers will change. And just like we said a minute ago, when I was in school in the 90s, none of what I do now existed at that time.
Yeah, literally. It's surreal. Like, I mean, even, I'm not super technical in my day-to-day work, but I mean, it's so much of it's changed already in the past year and a half. And again, like you were saying, even when I was in school, like, I think digital marketing was like just starting to happen. Like, social media was like a new-ish thing. And so it's like a lot of that has, like you said, it didn't exist 25 years ago. And so, how do you see that balance shifting between maybe technical roles and like business side roles? Do you see there being a change, or how do you think AI will influence that?
Well, I like the concept that Sam Altman has talked about, and I think Sam Altman is the CEO of OpenAI, and Bill Gates and Satya Nadella and several other business leaders have echoed, which is the idea that with these new tools, we could have companies in the future, potentially even billion-dollar companies, which have very small teams. I think Sam Altman's concept was like the single-person billion-dollar unicorn, because you can leverage these agents to do so many different processes, and that implicitly means that you have business people who are leveraging the AI to do technical roles, and vice versa. And I would say that that's true to some degree. I'm leveraging, like, as we're talking right now, I have a series of agents that are running several marketing and sales processes for me right now. And I get notifications from the AI about when I need to take action on that, or when a pivotal thing has happened. But it is making me considerably more, let's say, per hour productive for that role. Now, I've come from a sales and marketing background. I've been, I would probably self-identify as a marketer for like the first half of my career, and then I started to transition into more of a technologist for the latter half of my career. And that sort of reflected the overall evolution of the ad tech and martech industry as we went from big data to analytics to leveraging big data for training data, and that became machine learning, which became AI. But I'm not an engineer. And so today, a lot of the processes that I'm building for my day-to-day workflow, I'm leveraging AI for very basic, coding and building of processes, or connecting processes together, where previously it would have required an engineer to actually code those things. Now, again, that's not saying that it's replacing somebody's job entirely. There are still engineers who have to come in and build a lot of these processes. but it does make the average person more able to cross over between the business and technical, let's say, career tracks, so that there's a merging and an overall, let's say, exponential compounding factor that comes in. Like, here's an interesting experiment. I think this was in a book I read recently called, I can't remember the title, and I'll maybe we can put it in the show notes.
We'll put a picture here.
But it basically used the example of the thought experiment. No, this was an actual experiment. Somebody said, okay, I want to build a toaster.
Okay.
This was a few years ago. Now imagine what you would have to do to build a toaster today.
Yeah.
This guy actually, built like the brick forge so that he could melt down steel in order to, cast like the elements required in the toaster. It was something like a 2-year project so that he could make a piece of toast.
Forever. No, he can make toast forever now.
Well, now he can make toast, until it burns out, because he had to do his own soldering and everything, right? So it's probably going to not last that long. But that is basically like the story of human history, is that we have all of these compounding technologies, the forge that you can cast iron, and, electricity, and the whole concept of being able to heat elements. Like, all of this compounds into a very useful tool. A toaster is a very useful tool, right? Well, AI is very similar. It's the compounding of business and technology, career paths, all of these different things into being able to now do more useful things at scale, more per hour productivity is the end goal. And so now it's up to us to apply that to solving bigger and bigger problems. Things like, global warming, for example. That would be a good problem to solve. We can use our technology for that. If we have the tools, we can solve problems like that.
Yeah, I think that's a good place to kind of leave it. I think it's a good message. Is there any kind of final thoughts, anything you'd want to shout out? Also maybe like where people can get in touch with you, learn more about the product?
Yes, absolutely. So, first of all, for the career part of it, let's say to put a pin in that, I highly encourage people to do their own research. At this point, we're still early in the whole agentic AI phenomenon. So you have to read the literature, you have to read the papers, you have to read the books, or at least watch the YouTube videos that help you understand what these models can realistically do, and don't believe just the hype. Like, there are things that agentic AI can do very well, and a lot of things that it cannot do very well at all. So apply your own critical thinking to that process, and then map your career path accordingly. When it comes to our particular application of agentic AI and decision intelligence for retail and supply chain, if you are a retailer, or if you have a supply chain or a manufacturing process and you'd like to be more efficient with that process, come and talk to us. So you can email me at evan@keymatter.ai, or go to our website, keymatter.ai, to learn more.
Awesome. Thank you so much, Evan. Really appreciate your time, and thank you so much for coming back on.